Dev logic. Not so everyday logic for everyone.
Hi guys, my name is Oreoluwa Ogundipe, and we are going to be looking at an introduction to machine learning. It's going to be a machine learning starter pack, so it's pretty much just talking about machine learning basics and taking us through the different types of machine learning models one after the other. And so basically this is just the introduction right here, and also this is just there's an intro.md file in the GitHub repository for people to actually look through it. This is basically talking about what machine learning is all about. And before we delve deep into it, I just want to say machine learning is pretty interesting, really fun stuff. Basically, everyone hears about machine learning these days, but not so many people really know what it means. That's just because it's a lot of big buzzwords thrown all around. And basically, what machine learning is pretty much given the computer ability to actually predict future events from the data that's occurred in past and previous events. And so in the MD file, you can see that it says, it gives the computer ability to learn without being explicitly programmed. And basically that's just saying that you just have your data set before, and then you build your model and train your model to fit it to that data set. And so for future instances, when you actually bring in newer data with the same structure as the model, you can actually predict the results because you already have results of previous events, basically. And pretty much broadly two categories of learning: there's supervised learning, unsupervised learning. And supervised learning, what happens is that you're actually trying to predict something and your data set has labeled features. So basically it's more like this example over here. We're talking about a car, and for this one you can see that it's basically saying you have your data set which has the weight, length, the number of tires, and basically a last column telling you whether it is a car or not. Now with this is a supervised learning problem because your data set actually has the label, so you can tell that, oh, this is a car or this is not a car. Now the difference between supervised and unsupervised learning is that if you look through it, we can see that basically the unsupervised learning problems do not have the labels, the clearly labeled features over there. So your model, it's the job of your model to actually cluster and group the data into different clusters for it to actually read meaning of the data you have given and then work from there. And just a couple of advantages of machine learning: basically fraud detection, stock price prediction, house prices prediction, Netflix, how they predict your upcoming stuff, disease, also predicting diseases based off of different patterns, and Snapchat's adaptive filters. Man, everyone uses the dog filters these days. Anyways, examples of machine learning models: linear regression, logistic regression, neural networks, SVMs. And there are also a lot of available machine learning APIs. There's a TensorFlow, the scikit-learn, the Kairos API provided by Kairos, and the Microsoft's API. So there are also a lot more which I may have not mentioned over here. You can feel free to let me know if there's any more I may have left out from this. And basically, so this is just a quick introduction to the whole point of machine learning. So now we're just going to delve right into the fun part, which is the logistic regression that we're going to be looking at today. Now, what's logistic regression? Now, everyone has heard about machine learning and interesting, wonderful machine learning. But basically, what happens with machine learning is that you have your models which are following different functions, basically, and then you fit your model for the particular data set. Like you train your model with a particular data set and then generate results. Now with logistic regression, logistic regression is usually used for categorical data, basically your boy or you're not boy, or your car or your dog, things like that. Basically, is it a 0 or 1, pretty much. And so how that works is that you have your simple function, and then you now apply another function upon that to give you just one discrete result, either a 0 or 1. And we're going to just delve right into the code right now for you to actually see what we are talking about right here. Okay. Basically, we're going to be looking at this, and let's just expand this up. Sorry. Yeah, okay. Yeah, sorry about this, guys. Okay. Now it's all expanded. Now, before we go ahead, there's also a README file for this logistic regression, basically telling you the packages you need to import before you actually start working with this. Basically, we are going to be using scikit-learn provided by, it's powered by Google, last time I checked. Basically, we're using scikit-learn for our models. We're using pandas to actually help us import our data set. And we're going to be using matplot library to actually plot and visualize our features. Now, this first block that we're going to be looking at is how you get your data. Now, we're using pandas, so that makes life easy for us. So pandas has a read CSV function, which basically reads the CSV function and uses the delimiter, which is the commas, so to actually separate the data. And then we also have labels, which basically we are saying that get us the labels and store it in this and store that with this variable here. And over here, what we're saying is that now in the data set, our labels are M and B, and we actually want them as zeros and ones to make life easier for us, so that we can actually also use that for comparisons. And so right here, what this does is basically converts that, the zeros, the M to zeros and the B to ones. And we're working with the we're going to be working with the breast cancer data set, which basically has a couple of features and their labels as malignant or benign. And basically that makes life easier for us because it's either malignant breast cancer or benign breast cancer based off of our data set, and that's what we're going to be working with. Now, before we delve deeper into it, we also need to pre-process our data. Why and what is pre-processing of data? Pre-processing of data is pretty much where you actually adjust your data and actually split your data and basically normalize your data to actually make it usable for your machine learning model, so that it's not just scattered all over the place. Now, quick example of what I'm trying to say is basically, say with this our data set of the breast cancer, right? We have some features that might be as little, some values that might be as little as 0.01. We might have some as large as 150, and basically that would actually scale your data if we look at all of them with the equal scale, because one is so high, like a column is so high, another column is so small. So basically, the pre-processing of data is pretty much trying to make sure that all of them are normalized. So you have different functions that you can use, and we're going to be using the sklearn pre-processing normalize. So basically, this is normalizing all our features using the L1 normalization. And we split our data into the training data, the validation data, and the test data. So splitting of data, this is very important because we can't just use everything for training. We need to save some for validation and some for testing. And what's the training? Training data is what you use to actually fit your machine learning model. The validation data is what you actually use to see how well your model is doing. And the test data is also for further testing of your model, basically. And so what this function does is basically goes and then normalizes the data and then splits it into the training, the testing, and the validation, and it returns all this for us. Isn't it nice that Python lets you return all more than one thing? For people who use Java and PHP, so far in PHP, I haven't seen where you can return more than one at once, but yeah, Python gives you that. Anyways, and now we're also going to plot our features. Now, the reason why we're plotting it is just for us to have an idea of what things are going to look like. And when this function basically helps you to plot your samples, and we're just using two features because for two features that's two-dimensional. If we make it more than two features, it might be maybe a three-dimensional, and that's kind of getting a little more complex. So we just want to have them all in one scatter plot, basically just using red to identify the malignant and the blue to identify the benign breast cancers. And we're going to be taking into consideration the texture mean and the radius mean. So if we look through the code, we're using matplot library. So this plots the X label and the Y label, and then gets the legend, and then titles it, and then saves the figure into this. So you would find this in the repository as the visualized features.png. Now, down to the fun stuff, the logistic regression part of things. Now, for this function, we passed in four things. We passed in our training data, that's the X, and the Y, which are the labels, and we passed in the validation data, the X and the Y. So basically the features and the labels. Now, we have our class names, and we have our model itself. Now this model is the logistic regression model. Now the C right there stands for the error. Now with logistic regression, when you're trying to fit your data, before you know how good and how ready your data is, there's this thing called gradient descent. And for you to stop, the stopping criteria for the gradient descent can also be the amount of errors. And so what this is saying is that when the error is as low as this, then we can safely say we want to actually stop. And then we also have the solver, which is the LIB linear. So these solvers are the things that actually, so before you actually get your discrete 0 or 1 value, you might get like a continuous value, and then the solver is the next function you apply over it to actually give you your discrete 0 or 1 value. So we create our model called logistic regression with this, and then the next thing we do is we fit our model with the training data x and y. So there's a model.fit, and once we fit this, the next thing we want to do is also generate predictions. Now we use the model.predict with the validation function. So now we are trying to validate our data because we already have our model already fitted. Now we're trying to validate the data, and now the predict function basically takes in the set, that is the validation, all the features for the validation function, for the validation data set, and then tries to predict it with the model that has already been trained with the training data. And so that's what predictions is. And then now the accuracy basically is trying to find out how well did these predictions go on, like did these predictions work out right for us or not. And over here there's the accuracy score. Basically this tells us how good the model was, maybe 0.92, which is like 92%, 0.8, which is like 80%. But since this is something proper, this is like a breast cancer, this is a big deal, right? And you want your model to have like very, very, very high degrees of accuracy, about 0.99999. If you can get all that, that'll be beautiful. But this is just for training and understanding purposes, so we're not too concerned. Well, obviously it's really important to care about the accuracy of your model, but right now we're just showing how to actually make logistic regression models to actually generate predictions for you. So basically what this does is gives you your accuracy score, and then this confusion matrix basically is gives you in the form of basically telling you which ones were false positives and which ones were true positive or true negatives or whatever. Basically what false positives are is basically saying, oh, which ones out of the validation data did the model predict correctly. So which benign breast cancers did the model predict as benign, which malignant breast cancers did the model predict as malignant, or which malignant breast cancer did the model mistakenly predict as benign, or which benign did the model mistakenly predict as malignant. So that would give you in sort of an array, like a tabular form basically. So this telling you, oh, this, like almost, I don't want to draw it here, you'd see it when we actually look at the results. And then there's also the classification report, and these are just some print statements, basically just printing you, telling you how your validation model, how your model did with the validation data, and the classification report, and also gives you the confusion matrix. And over here you just return the model for further testing afterwards. Now, the next thing we want to look at basically is how the testing of the whole thing works, right? So we actually test the whole part of the testing data, but I actually singled out a particular sample to actually show you basically, oh, you can actually use a singular sample. If you provide a singular sample with all these features, this is what our model is going to predict it as. So this feature here, the random value gets a random value, the prediction helps to generate predictions over our whole testing data. And now we pick a singular random value from like a singular one, maybe the test x of 0 or 1 of 200, whatever. Pick that and then see how the model predicted it as and what was the truth then. And over here, these are just some print statements, and this is how you actually call the function. Basically, we actually return our features, the labels and the temporary values, return the validation, the testing data, and then we plot the features and it's stored in the images folder. Then we get our logistic model, and then we test our data. And so now we are going to go over here to actually run it to see how things actually work. So let's cd into the logistic regression. Let me just clear this. And so if we do an ls, we see this is the logistic regression, the py. So we just need to run that using the Python logistic regression. the pi. Now when we run this, it might take a while, and then this error, warnings right here, no errors, are basically telling us that the pyplot.hold is depreciated. But what we're really concerned with is from here on out. So let me just let's just concern ourselves with this from here, right? So it tells us the accuracy of our model, and it told us our model had an accuracy of 0.92, which is about 92%. Like I said, we're working with proper human, like if you're gonna make this thing for commercial use, this is actually for human beings, and you don't want to predict the wrong thing for the person, right? And so, but right now it tells us the accuracy of 0.923%. I mean 92.3%, and this is our classification report. So this tells us our prediction, our recall, and our support, and the F1 scores. So this is also our confusion matrix, and then we can also see here that the chosen sample, so this basically tells us the features for our chosen sample, like how our chosen sample did basically, and tells us over here that for this sample, our model predicted the breast cancer to be benign, and it truly was benign. If we run this again, it may or may not give us the same thing, but let's see again. Sorry, I take a while. You know, it's done plotting, and we're about to begin to go. Basically, yeah, so it basically showed us the same thing again, that the breast cancer was predicted to be benign. Like, obviously, in our data set, we have more benign labels than malignant labels, which is why this might be the case. But this are random values. Like you saw in the code, we actually picked random values to be used, like random positions to actually show us the result for that. And so basically that's just a brief intro into logistic regression for machine learning, and this can be applied in so many ways. You can apply this in, I don't know if you guys watch Silicon Valley, the hot dog or no hot dog kind of stuff. Basically when you are working with like your problem is basically to decide whether something is this or not, whether it's A or B, and you're working with data with proper labels, then you can actually pre-process your data, feed it into a logistic regression model, and then you have wonderful results to actually continue. Well, thank you for watching for this long and for following through with me. If you have anything interesting that you may want to see or any comments, just leave them in the comment section for constructive criticism and then we would be good to go. Well, that's all for now, and thank you for your time. Bye.